Hi, I'm Jeremy. I'm going to talk about our work Skin3D, which is our approach to detect pigmented skin lesions in 3D meshes and then track those lesions across subjects imaged in different poses. There has been significant research efforts to automatically classify or diagnose 2D skin images, where some works are now showing machine automated diagnoses are comparable to human expert level performance when using 2D skin images. Whereas in this work, we're interested in 3D skin imaging, where 3D colored meshes are acquired using specialized equipment, which we see as a promising new direction for full body screening. A 3D mesh is composed of 3D vertices and connecting edges, as well as a texture image that shows the color of the surface of the skin. For this work, we relied on the dataset 3D body text. This dataset is composed of 3D human subjects with color or texture information. There are 200 subjects imaged in 2 different poses. We observed that there were pigmented skin lesions or moles that were visible on the skin but were not annotated. Our overall computational pipeline starts with 3D textured meshes, where we detect lesions on the texture image and then track the lesions in 3D across the subject image in 2 different poses. We see this work as a first step towards a full body detection of moles that gives the potential to track changes to moles across time. This is particularly important for monitoring lesions that may be malignant. In addition to the computational pipeline, we focused on data. As mentioned earlier, the moles on 3D body text were not annotated. To the best of our knowledge, there did not exist a large-scale public data set of 3D meshes labeled with skin conditions. So in this work, using the 2D texture image, which you can see on the left, we visually inspected these texture images and manually placed bounding boxes around regions that appeared to contain a pigmented skin lesion, which are these green bounding boxes on the image. We used the annotation software, VIA, which allowed us to efficiently annotate over 25,000 locations from 200 subjects. Now, this gives us a source of data to train and evaluate our approach to predict bounding boxes on the 2D texture images. We trained a faster region proposal CNN on our manual annotations. You can see our manual annotations in green with the predicted bounding boxes by the CNN in red. We map these detected lesions back to the 3D body, as can be visualized here, where the red boxes indicate the automatically predicted locations that may contain a mole or a pigmented skin lesion. After we detected these moles, we are interested in tracking the moles across the same subject in different poses. This is important if we want to track or monitor a lesion across time to see how a lesion may change, as a changing lesion may indicate melanoma. Here we show specific lesions annotated with numbers, where the corresponding numbers indicate matching lesions. For example, the 9s on both bodies indicate the same lesion. The colored lines indicate a match as determined by our proposed approach. We provide both the manually annotated bounding boxes, the green boxes, and the manually determined lesion correspondence of a subset of select lesions, these numbered lesions, in our data release, which I'll now talk about. To further support research, we have released our annotations and some supporting code to load and process the bounding boxes. The directory is structured as follows. We provide the annotator bounding boxes, examples of how to load the bounding boxes, and code to support loading the bounding boxes. We'll focus on the data directory as highlighted here. This is composed of a directory with single annotator bounding boxes and lesion correspondences. The second directory includes multiple human annotators for each mesh in the test set to allow us to compare multiple human annotators with our predicted annotations. And finally, we include a CSV that describes the train, valid, and test partitions. We provide more examples of how to work with this data in the notebook directory. We refer to the paper for more details on the method, as well as the code that's available online in the link shown in this slide. Thank you.